So we did neon, now we're gonna do chlorine.
Chlorine.
Yes. So find chlorine on your periodic table.
Found it.
All right, and I really should just close this document because I keep opening it up. Let's go to paint, and then we're gonna look at chlorine. So Mitchell, can you tell me what atomic number is chlorine?
It's 17.
17, good, yes. It's really close to neon here. So when we're drawing chlorine, we can start off by, I guess, even just writing down the atomic symbol or even just the name for this. So here we're gonna do chlorine. And so your first step, as always, you need to have the number of protons, number of electrons, and neutrons. So your number of protons is equal to the atomic number here, which is 17. 17. And in an atom, that is also equal to your number of electrons. So your electrons is also equal to 17. Now for your neutrons, we're gonna go up here. We take our average atomic mass and we're gonna round it. So we have 35.45 and we're gonna round that to the nearest whole number. So using your rounding rules, if it's 4 or lower, you're gonna just leave the number as it is as the whole number, or if it was 5 or higher, you'd round up. So this one here rounds or just stays at 35. And so we're gonna go 35 minus that atomic number, which was 17. So 35 minus 17. So what is 35 minus 17, if I can throw you on the spot?
That would be 18.
Awesome. Good mental math there. Awesome. Okay. So that means that there are 18 neutrons. So that's just, I really like this example because it shows that your number of neutrons doesn't have to equal your number of protons. So it just depends on what's happening with that atomic mass. You know, it could be off by a couple, sometimes it's off by a little bit more. It just depends on what that atomic mass is. All right, so now that we have our protons, electrons, and neutrons, we can go ahead and start drawing that Bohr diagram. So we're gonna start by drawing our, the nucleus. So we first need to start off with the atomic symbol, which is Cl. I apologize with my font that this looks like Ci, but that is a Cl.
You could almost use a cursive.
Yes, and actually, if you guys looked on my notes, I actually use a cursive L when I'm able to. So just because, you know, with right now it literally looks like an I. So if you can use a cursive L, but do not put it as a capital L, because then that means that's a different element. Okay, so next thing in my nucleus, I need the number of protons, which I'd found was 17, and my number of neutrons, which I found was 18.
It's all coming together.
Good, yeah. And then, so then I'm going to draw my nucleus and I'm going to shade it in. So it doesn't need to be anything fancy, just a nice light gray, just to show that it's your nucleus and that you've shaded. And now we can go ahead and start drawing our orbitals. So we're going to start off with the first one, which I once again put it in gray. There we go. And I can go ahead and start drawing my electrons. So remember, in your first orbital, you can only have a maximum of 2. So those are always going to go in the same place. So you have 1 and 2.
You got another one, and then you put down more.
Exactly, yeah. So now I need another circle. And I'm going to draw in. And so remember, with this one here, I'm only allowed a maximum of 8. Okay, so we had 1, 2, 3.
4. 5.
Whoops. 5.
6. 7, 8, 9, 10.
So that means we need another one, correct?
Yeah.
Awesome. Okay. And one more here just to fill it up. So yeah, if you're moving to another orbital, you should see that your previous one should be filled up. So in your second one, you're allowed 8, and then the third one, you're allowed 8 as well.
Is it a maximum of 8?
Yes. Yeah. So your first one has a maximum of 2, and I can write this over here. So first level has a 2 max, and then your second and third level will have a max of 3 as well, or sorry, a max of 8.
Move my thing.
So we are actually only able to do the first 20 elements, because then there's actually some complicated rules that you guys could potentially study in Chemistry 30. So we only do the first 20 elements. And actually by the time that you've done the assignment, you've done the practice, you've done all that kind of stuff, you've actually done all 20 elements. So hopefully Bohr diagrams by this point should be fine by the time you're done this assignment. Okay, but anyways, let's finish off. So we had 10 going on, right? And we need a total of 17. This would be 11. Whoops, that's a really awkward one. So there's 12, 13, 14, 15, 16, and 17. Okay.
Wouldn't we need one more because it's 18?
Well, so remember, this is the number of neutrons. So the neutrons belong in your, and that's fine, your neutrons belong in your nucleus. So we're just drawing the electrons. So this here is the number that we're going to want here.
Oh, okay.
So they might not necessarily have full orbitals. The previous one did because it was actually, if you want to know, because it's a noble gas, it's going to have full shells. Anything in this column here is going to end off on a full valence shell. So it means all of your orbitals are going to be full. Do you also want a little hack with drawing Bohr diagrams?
Sure.
I will reward you since you're watching this video or participating in our Zoom. So how do you know how many orbitals you should draw in total? So a little trick is it depends on what row it's in. Neon had 2 rings or 2 electron shells. It was in the second row. Chlorine is in the third row, so it has three electron shells. You had 1, 2,
Oh, that is a nice little hack.
Yeah. Okay, so then also a nice little hack here is your first row only has 2 elements. Your first row can only have a maximum of 2 electrons. Moving to the second row, you have 8 elements. You can only have a maximum of 8 electrons. Third row, you have 8 elements. You have a maximum of 8 elements. Isn't that great?
It's all coming together.
It is all coming together. And like your periodic table, like honestly, this, like Dmitry Mendeleev was like, he's an amazing genius. How this all worked out to be so great. I mean, my brain can't even comprehend how, like, the amount of work that must have went into this. But like, it's amazing. Like, so if you were to do a Bohr diagram for hydrogen, it has 1 electron. Helium has 2. If you were to do lithium, it has a full valence shell for your first one, and then it only has 1 in the second. Second row, first element means 1 electron in an outside shell. So say if we were to look at oxygen, it's going to have 2 total rings, your first one being full, and then you just count the number of atoms or elements. You have 1, 2, 3, 4, 5, 6. So that tells you it's going to have 6 electrons in that outside shell.